Okay, there's one other thing I want to mention in terms of algebraic identities, and we might do a second example of this, because it's a fairly common question to come up. So, this is something known as completing the square, and it involves writing a quadratic, which I have here as an example, in a very particular form. So, if we have this quadratic, 4x squared plus 10x minus 27, we want that to be the same as some constant p times the quantity x plus r squared plus s. Now, as we'll meet when we come to our study of quadratics, this particular form will tell us a lot about the behavior of the quadratic curve, i.e. where its lowest and or highest point is, depending on the particular value of p that we're going to be choosing. So while there is a method to do this using a couple of other, like particularly avoiding the use of identities, and there's just a sort of step-by-step process, again, I'm of the belief that you don't need 10 different methods to do 10 different questions. You can get away with doing the same methods for a lot of questions. So that's what we're going to do here. Firstly, what I'm going to do is I'm going to keep the left-hand side completely bare. I'm not going to touch that. And we'll instead just expand out p times x plus r squared plus s. So we'll have p times x squared plus 2rx plus r squared plus s, not plus p, that's definitely meant to be plus s. And then we expand the p outwards, and I might as well just write the left-hand side back in. We get px squared plus 2rpx plus pr squared plus s. And again, we'll do the thing that we always do with identities and just compare the coefficients. So if we take a look at the x squared terms, it's the easiest one to kind of spot. On the left-hand side, we have a 4x squared, and on the right-hand side, we have a px squared. So, of course, that's only true when p is identically 4. Then if we look at the x to the 1 terms, on the left-hand side, we have a 10x. And on the right-hand side, we have a 2rpx. Now, the x's are going to cancel, and we know what p is. We know p is 4. So we get 10 is identically 2r times 4. So we get r is 10 over 8, which is 5 over 4. Okay, now we're going to move on to the last one, the x to the 0 terms. So on the left-hand side, we have negative 27. And on the right-hand side, we have the quantity pr squared plus s. Now, I am going to have to use a calculator for this, just to be doubly certain. So subbing things in, we get negative 27 is identically 4 times 5 over 4 squared plus s. So you get negative 27 is identically 25 over 4 plus s. So if we do negative 27, subtract that, we get s is minus 133 over 4. So that implies that we can write the quadratic 4x squared take away 10x plus 10x minus 27. In the form, well, p we know is 4, so 4 times x plus r, so x plus 5 over 4, squared, subtract 133 over 4. Okay, and that's how you write that quadratic in a completed square form.